Hello viewers, we're going to take you through the story of A-level pure mathematics. And in this video, we are going to go through the marking guide for Senior 5 Math Paper 1 end of term 2 for the year 2024. So this video is suitable for students in both Senior 5 and Senior 6 offering principal mathematics as part of their combination. So this is what we hope to upload in this solid D. What is ticked means is already available on the platform, and what is not yet ticked means will be uploaded with time. So if you're in Senior 5, there are books I recommend to buy, and in Principal Mathematics, there are 4 books: Math Paper 1 notes, Math Paper 2 notes, Term Paper with marking guides, and a topical question bank. Subsidiary Math is only 1 book with notes, term papers, and also past papers. Physics, there's 4 books: Physics Paper 1 notes, Physics Paper 2 notes, topical question bank, and its solution. So for any of the copies, call on this number. So now we shall begin with section A. Section A, question 1 says, solve the equation 4 logarithm of x base 3 minus 2 logarithm of 729 base x equal to 3. So the first thing to realize is that these bases are different. So you need to be confident with how to change a logarithm from one base to another. But this value can be prime factorized. So prime factorizing this gives you 3 to the power 6. Then this one can go here to become 12 logarithm of 3 base x. Then to change this to base 3, I will now get 1 over log of x base 3 times 12 to give, that's why you see 12 up here. Then you can let y be equal to log of x base 3. Then you substitute where there is x log x base 3 for their y. Next is to multiply throughout by y and rearrange to get a quadratic. Then I can use the quadratic formula to get the 2 values of y. Now from there we shall remember that we are the one introduced in the y, so we have to bring back the x. By saying this, put back log x of base 3, log x of base 3. Then from there I need to eliminate logarithm by saying this to power this is equal to this. This to power this is equal to this, like that. So let's first see the marks for this slide. Then we can now eliminate the logarithm. Then use the calculator to come up with that. But logarithm should be a whole number, so it can be this, therefore it is that. And that's what they wanted. Then question 2 says, if the polynomials this and this leave the same remainder when they are each divided by x minus a, find the possible values of a. So here we shall come and say that let this polynomial be fx and this be gx. And the divisor is x minus a. When you go to 0, you get x equal to a. So what I'm going to do, I will substitute a wherever there is x here to get its remainder, and also a wherever there is x to get its remainder. But they say they are the same, so you can equate the 2. So I'll come and substitute. Then simplify. This and this goes away. Then, okay, now I remain with a squared. This one comes this side to become negative 7a. This one comes this side to become positive 12, which is a quadratic, and you can use the quadratic formula to get the 2 values of a which they want. And that's what they wanted. So that was question 2. Question 3 says, find the condition that the line this is a tangent to the ellipse this. So the first thing to do is to make y the subject in the line and then you substitute that y in the equation of the ellipse. Then from there I have to simplify. For expanding this gives you denominator is L squared, then this one alone. So the negative goes because of the square, then this squared, then here this one is twice the product of the two terms. Multiply throughout by L to get that. So now from there, after expanding, after cross multiplying, we can now rearrange x squared alone, x alone, and constants alone. Then from there, I'll remember the condition for tangency. So for tangency, we have repeated roots. Then I'll come and substitute for b, for a, and for c. Then from there, I realize that in this one, b squared is common, so I can pull it out to come up with 4b squared outside. Then this remains as it is, then this becomes that. Now from there, this 4 can cancel, and this b squared can reduce this to 2. So I'll come up with now m squared n squared b squared. Then this one I'll expand now. I'll expand this one alone here to come up with this. So this with this gives you this term. This with this gives you this term. This with this gives you this term. And this with this gives you this term. Okay. Then I open this square bracket to come up with that. And from there I realize something. Do you see this? And this? They can cancel to remain with this, this, and this. Okay. Then from there I'll realize that, do you see this? We have this. So it can reduce this power also. And also this one. So it is common. I can divide throughout by a squared, L squared to remain with here negative n squared, here remain with a squared L squared, here this one goes away to remain with m squared b squared. Okay. Then take this one, this side, to come up with this, then this side remains with that. And that is the condition, because they only wanted you to get the condition in a simplified form. So now we shall go to question 4, which says that prove that this is equal to that. So it is advisable to start from the left-hand side since it has more terms and can be simplified. So the first thing to do, I can use the reverse of factor formula, but there is no 2 here. That is why I'm first multiplying throughout both up and down by 2 to come up with something like that. And now I can use the reverse of factor formula. So reverse of factor formula, if it is cosine and sine has a bigger angle, it becomes sine plus sine. If it is cosine and sine has a bigger angle, sine plus sine. Here it is cos, it means it is cos plus cos. Sine becomes cos minus cos. Then how do you get the angles? Angles, you simply add and also simply subtract. Add to get what is here, subtract to get what is here. Add to get what is here, subtract to get what is here. Add to get what is here, subtract to get what is here. Add to get what is here, subtract to get what is here. And that is it. Then from there you will realize that this and this can cancel. This and this can cancel. So remain with this, which can be simplified by factor formula. Sine minus sine, it is cos sine. So cos has a bigger angle. So this plus this is 20, divided by 2, you get 10. This minus this is 8, divided by 2, you get 4. So apply to the one down. Then but the one down, you see there is a plus. That's why we get cos. So these identities are available in the logbook. Then the 2 can cancel, the cos 10x can cancel, remain with this over this, which gives you tan, and that is what they wanted. Then question 5 says solve the equation this for that. So you shall come and first rewrite the equation, then remember next that this can be got in terms of tan. So sec squared x over 2 is the same as 1 plus tan squared x over 2. Now I can let, or you can rearrange into a quadratic. So opening brackets, I've got that. Then rearrange into a quadratic, begin with the squared term, the term with x alone, and the constant. Then I can use bulldozer or quadratic formula to get the 2 values of tan x over 2. One of them is 1, another one is negative 2/3. Inverse of this gives you this, inverse of this gives you that. Then you can multiply throughout, cross multiply to get the value of x. And that is what they wanted. Then question 6 says, if alpha and beta are the roots of this, express this in terms of p and q. So for the given quadratic equation, we need to get the sum and product. Sum is negative of this, and product is that. Then I can write the given expression, open brackets. So this with this, this with this, this with this, and this with this. Then I can substitute the product here is true. Also this product is true. Now this one I factorize to get this. Factorize out negative 1. Then this one can also be expressed in terms of sum and product to give you this one which is in the box bracket. Then I can substitute for the sum, negative p, and also here negative p, product is true. So next is to simplify. When I open brackets, I'll come up with that. And basically that's what they wanted. Then question 7 says, find the area of a triangle with vertices that. Area of a triangle. So there are many methods, but since you have not covered vectors, we shall use this method. So what you do, you first arrange them vertically. They are vertices. This one is for this. Then bring on this. Then bring on this. Then end with the first, the one you began with, to form a closed pattern. Goes from A to B, from B to A to C, from C to A, to be closed. Then from there, I'm going to do something funny. I'll say this times this gives you 12. This times this gives you 8. This times this gives you negative 8. Okay. What about here? This times this gives you, oh, now here, this one is a sum. When you add these ones, you get 12. Then you also go this side. This times this is 4. This times this, negative 24. This times this, positive 8. Then you also add to get negative 12. Then from there, area will be half of the magnitude of the difference of the sums. Half the magnitude of the difference of sums. So this minus this, magnitude form, and there's also half. If it was a parallelogram, it would have been, the half wouldn't have been there. It would have been just magnitude of the difference of sums. This gives negative 24, but because of magnitude, it becomes positive 24. Times a half to get 12 square units. And that is what they wanted. So now we shall go to question 8. Question 8 says, express this in the form this and hence state the coordinates of the turning point and the nature. So this means we have to factorize. To factorize, you have to first make the coefficient of x squared positive 1. But then this time it is negative 2. So what we do, let me first pull out the negative 1 to come up with that. Then from there, I'll pull out the positive 2 to come up with this. Okay. Then now that the question is positive 1, I can now complete squares. Complete squares means you replace this with x, then this with half of this is what you put here. Brackets, you put a squared term minus the square of what is here. That is called completing squares. Then you simplify by opening the box bracket, you come up with this. Then you collect like terms. This plus this gives you 89 over 16. Then minus this, which is here. So it's already in this form, and that's what they wanted. Now shall go to the hence part. For the turning point, it means the squared term is 0, giving you x equal negative 3 over 4. And when the whole of this is 0, it means that the value of y will be this. Therefore, the turning point is the maximum. Maximum because this part is negative. X squared is negative, the highest degree. So it's the maximum, and the coordinates are this with this. And that's what they wanted. So that was section A. Now we shall go to section B. Question 9 says, part A, find the values of A and B given that this is equivalent to that. So that is now under partial fractions. I think let's first deal with that. Under partial fractions, so we shall first get everything under the same LCM, then we can equate the numerators. But don't forget the equivalent sign. Don't forget the equivalent sign. So now I can come and say that putting x equal to 4, my aim is to make this 0. I'll come up with where there is x, I'll put there 4. And here 3 times 4 gives you 12. So there I can get the unknown b as 2. Okay. But I also need to get the value of a. So value of a here, if I make it 0, it means x is equal to negative b. Therefore, I need to just get any other value of x, which is simpler. And of course, the base is x equal to 0. I'll come up with that, substitute for b, and make a the subject. And that's what they wanted. Then for part B said, express in 2 partial fractions the whole of this. So here what you should remember is that it is a proper fraction. It is a proper fraction with some repeated roots. So this one can be split into 2, a over that and a over this with the power 2. Then this one is only 1 to give you this, where this is now a linear. Then I can equate the numerators. For this, it means a will be a times x minus 1 times this to be that. Then for b, for c. Now I'll do the same thing, putting different values of x. So if I want to make the whole of this 0 and the whole of this 0, I'll put x equal to 1. X equal to 1, I'll get here 6 minus 7 minus 1 plus 6. Then the whole of this is 0. The whole of this is 0. I'll remain with this part, which is b. Then brackets x plus 1. So I'll simplify to get the value of b. What about when I put x equal to 0? X equal to 0, the whole of this is 0, so remain with only 6. Then here I'll get a, then here negative 1, positive 1. Then there is b, positive 1. Then there is the whole of this is 0, so we get D and positive 1. Simplify and substitute for B to get the equation, equation 1 with A and D. Then also choose another value. So here you just keep on choosing different values, but they should be smaller to avoid complexity in simplifying. So putting x equal to -1, I'll come up with that. We can be simplified to get equation 1, to get equation 2 now. Now there are two equations, but do you see something? This one was D minus A equal to 4. And even here, I have some D minus A. So where there is D minus A, I can put there 4. So it becomes 4 minus C equal to 4. That means I can get the value of C. Then putting x equal to 2, I'll come up with that, which can be simplified. To get also equation 3. So I have two equations with A and D. I can now solve them. So subtracting, it means this goes away. This becomes 6A. And this becomes -6. So A will be -1. When I have A, I can go back to equation 1, substitute for A to get the value of D. And then I can express the given fraction into partial fractions. And that's what they wanted. Then question 10 says, part A, express this in the form this, and hence find the maximum and minimum values of the function. So let's begin with that. So this one can be changed into double angle to give you this, and also this can be changed into double angle to give you this. So using the half angle property, it means you can get that. Then you expand this, and this is 3, so 3 times 1, 3 times this, and this one here. Okay, now my aim was to remove this square. Now I've removed it. I can now use the error formula. We use the one which is given, then you expand it, but remember to use the equivalent sign. So next we'll be comparing. I have cos 2 theta here and cos 2 theta here. When I remove it, I remain with 3 here. Here I remain with 3, r cos alpha. So r cos alpha is 3. Then here, sin 2 theta, sin 2 theta. Then 4 is equal to r sin alpha. Then I can divide the 2 to get the value of alpha. Answer to 3.13. Then get square root to get the value of r. So after getting r and alpha, I'll go back and remember. Now I can come back, replace r here and alpha here to get this. But the whole of this was here, meaning that what they want, there is also a plus 3. That's why they gave you this plus k. So in this case, our k is 3. So I'll come and say that this will be equal to that. And that's what they wanted. Then for the hence part, they wanted maximum. Let me first go back to the question. Maximum and minimum values of the function. So maximum for sine is +1 and cos is +1. Minimum for cos and sine is -1. So I'll come and say, if they want maximum, replace this with 1 to come up with 5 times 1 plus 3 to give you 8. When they want minimum, replace with -1 to get 5 times -1 plus 3 to give you -2. As simple as that. Now, part B says solve this for values of x theta ranging from 0 to 360. So that is what is given. I'll choose to use factor formula because you see cos. So cos minus cos gives you -2 sin. So -2 sin, this plus this, let's do something. This plus this, do you know what happens? This -45 goes away. Then you remain with 4 theta divided by 2. That's why you see 4 theta divided by 2 here. Then this minus this, it means this goes away. You remain with 90 divided by 2. That's why you see 90 over 2 here. Then simplify. Sin 45 is 1 over √2. Then make this the subject. So we come up with -2 over 2. Next is use a calculator. So 2 theta has values this, and that. I believe by now you know how to get those multiple angles using a calculator. Then divide by 2 throughout to get this. And that is all. Okay, now question 11. Question 11 says, part A, solve the inequality this, but remember they are magnitudes. So magnitude means plus or minus. So to remove the plus or minus, you square both sides. So I'll square both sides to get that. Expand, open this bracket, this gives that, this with this, and this with this. Then you rearrange. Take this side, you get this. Take this side, take this side, you get that. So that is a quadratic equation, quadratic inequality. You need to get the critical values by first factorizing. So sum, I need factors whose sum is 2 factors whose sum is 8 and product is 7. So those factors are 7 and 1. Therefore, split the middle term. 8x becomes 7x plus x. Then you factorize by grouping this alone and this alone. Then now you factorize out completely. This is common with this. Then you remain with 7x plus 1. The next is to get critical values. When this is 0, you get x equal to -1. When this is 0, you get x equal to -1 over 7. So note that you have arranged them in ascending order. Reason is because we're going to draw a table of signs, so I need to get values before this, which is x less than -1, then values between this, which is x greater than -1, but less than -1 over 7, and values after that, which is x greater than -1 over 7. So we shall come and draw. So for x less than that, we have that. We can use a value like -2, negative, so in the end it gives them positive. Then between -1 and -1 over 7, we can use what, -1.5. No, -1.5. We can use 0.5 because 1 over 7, let me first see, 1 divided by 7 is 0.1, -0.1. So I can use -0.3, -0.3. So it gives a negative there. Here it gives a positive, so in the end you get a negative. Then values greater, I can even choose to use 0, where I get a positive here, in the end it's a positive. Then I go back to the question. The inequality was less than 0, so they should be negatives. They should be negatives. And the negative range is here. So the solution set is this. Then part B says solve the inequality this one. Okay. So we need to first factorize that cubic equation. So we shall let fx be equal to that cubic equation. Then we first use try and error by testing. So when I put 3, I'll come up with a 0, meaning that 3 is a root, therefore x minus 3 is a factor. By long division, I'll get the divisor here and also the polynomial here. Then I'll long divide. This divide by this, you get x squared. X squared multiplied through the divisor, you come up with this. Subtract the 2, you come up with this. Then again, the whole of this divided by x, you come up with positive 4x. Positive 4x multiplied by through the divisor, you come up with that. Subtract the 2, you get that. So again, this divided by this, you come up with 4. 4 multiplied by the divisor, you come up with that. Subtract, you get no remainder. That is one alternative. Another one can be by synthetic method. So synthetic, we are interested in the coefficients. So coefficient of this is 1, of this is 1, of this is negative 8, of this is negative 12. Then put here the root. Then first bring this one down. Then multiply this by this to get what we put here. Then add these 2 to get what we put here. This times this to get what we put here. Repeat the procedure, add these 2 to get what we put here. This times this, you get what we put here. Then add the 2, you get 0, meaning that there is no remainder. So n of the 2 is okay. I think realize that even here, this is the coefficient of this, coefficient of this, coefficient of that. Then I can factorize this to get this. So the critical values are those. Yeah, so in ascending power, we begin with negative 2 followed by 3. So I'll come and look for values before negative 2. I can use negative 3. Here is negative. Yes, positive, so we get a negative. Values between negative 2 and 3, I can choose 0. So it's negative, positive, and with the negative. Values after 3, I can choose 4. So that will be positive, positive, positive. But my value, you see, greater than 0, meaning they should be positives. Therefore, the solution set is this. And that's what they wanted. Then question 12, part A says, solve the equation this. So let y be equal to that, which is here. Then you can come and replace where there is that, we put there y. So this negative power can be removed by getting a reciprocal, then multiply through by y to get a quadratic, which can be solved using the quadratic formula to get the two values of y. But remember, we are the ones who are introducing the y, so we have to bring back the x. Okay. Then I have to make x the subject. So using a calculator, this gives you this, and this gives you that. And that's what they wanted. Then part B, says a polynomial px of second degree is such that p1 is equal to 2, p negative 1 is equal to 0, and p2 is equal to 9. Find the polynomial. The good thing they have told us of degree 2, meaning it's a quadratic. So I can let be in that form. Then p1, I substitute where there is x, I put there 1 to get equation 1. P negative 1, where there is x, I put negative 1 to get equation 2. And P2, where there is x, I put there 2 to get equation 3. So those are 3 equations, 3 unknowns, meaning they can be solved simultaneously. So let us start. Equation 3 minus equation 1, I'll come up with that. Equation 3 minus equation 2, I'll come up with that. Simplify to get equation 5. Then now these are 2 equations, 2 unknowns. So equation 4 minus equation 5, I'll come up with that. Where this cancels, we remain with a, where a is now 2. After getting a, I'll come and say that from equation 5, substitute for a to get the value of b. Then from equation 2, substitute for a and b to get the value of c. Therefore, the polynomial is that, and that's what they wanted. So question 13 part A says, when a polynomial this is divided by this, the remainder is 7. And when it is divided by this, the remainder is negative 8. Find the remainder when fx is divided by this. So what you should realize is that this one is got from this and this. That's the first thing you should realize. Because if not, then it will become complicated. So let the remainder be in the form that, because when the divisor is quadratic, the remainder should be linear. So Rx is now that. So that means that I will substitute. When x is equal to negative 1, remainder is 7. When x is 4, remainder is negative 8. So I'll come when x is negative 1, remainder is 7 to get equation 1. When x is 4, remainder is negative 8, I can get equation 2. 2 equations, 2 unknowns, I can solve simultaneously by subtracting, whereby this n cancels, remain with m, which will be 3, negative 3. Now, from there, I can use equation 1 or equation 2. Choosing equation 1, substitute for m to get the value of n. Then you can rewrite the remainder, and that's what they wanted. Then part B says the remainder when the expression this is divided by this is 5 times the remainder when the same expression is divided by this, and 12 less than the remainder when the same expression is divided by this. Find the value of a and b. So this was more of English. So let that fx be the polynomial. Then when divided by that, so here I'm just getting the values of x, which I'll be using. So based on what they gave us, remainder when x is 2 is 5 times the remainder when x is 1, when divided by x minus 1. So I'll come and substitute to get fx here, 5 open brackets f1. Simplify, you'll be able to get equation 1. Then go to the next condition. They said 12 less when divided by x minus 3. So substitute f2, f3 minus 12. Simplify, you'll get equation 2. So here, and the good thing here, the b has cancelled, so I've got the equation 1 straight away. After getting equation 1, I can now get, so after getting value of a, I can now get the value of b. And that is what they wanted.